Alright, so to talk about something that resembles a division with matrices, we are going to need something called inverses. And to get to inverses, we need to start with what's called an identity. The identity, or the multiplicative identity, if you want to think of it that way, of the multiplicative identity of the real numbers, rather, is just 1, because if we multiply by 1, we just get the original number back. And it doesn't matter which side we're multiplying on. If we're multiplying on the left or the right, we get back our original number. Now, the whole multiplying on the left or the right with the real numbers seems a little silly because we're talking, that sort of multiplication is commutative. We already know that multiplication is not commutative with matrices, so it does we need to specify those two separately if we're multiplying on the right or if we're multiplying on the left. And the identity with matrices is actually a square matrix in all cases, and it's going to be a matrix where we have ones along the diagonal and zeros elsewhere. That may seem somewhat familiar because when we were trying to do the RREF method, the left-hand part of the augmented matrix was, well, we were going for an identity over there, with ones along the diagonal from the upper left to the lower right and zeros elsewhere. Alright, so let's just look at a couple of quick examples here. If I'm multiplying this, I'll do this matrix multiplication by hand, so if you want to see more examples, you can. You can also just try plugging this into your calculator, but let me just show you what's going on here. When we're talking about the identity matrix, we can there's all sorts of different identity matrices. There's a 1 by 1, there's a 2 by 2, there's a 3 by 3, a 4 by 4, and so on. All of them have ones along the diagonal, and in general, we just refer to them as I. And you kind of gather through context which I we're talking about, which identity matrix, and you just use whichever one is appropriately sized for whatever you're multiplying by. In this case, if we wanted to find I times A, well, let's see, A is a 2 by 3 matrix, right? And if we're trying to do this multiplication, we need the inner dimensions to match, so that's going to have to be a 2, and this is a square matrix, so it's going to have to be the 2 by 2 identity. So that looks like this, 1, 0, 0, 1. So I would do this multiplication, 1, negative 3, 2, 0, 5, negative 1. And when I'm multiplying this, I take this row by this column, and, well, I take 1 times 1, which is 1, 0 times 0, which is 0. This is going to give me 1 plus 0, which is 1 right here. So row 1, column 1, we get 1 times 1 plus 0 times 0, which is 1. For the first row, second column, this one right here, I'm going to take 1 times negative 3 plus 0 times 5, which gives us negative 3. And similarly here, you'll notice that what's happening, whatever number is in the top part here is just multiplied by the 1, so it stays the same. Whatever's in the bottom part is multiplied by the 0, which means it goes away. I add them together. I'm just going to get the 2 there. And now, when we move down to the second row, you'll notice I'm now going to be using 0, 1. 0 times the first number and 1 times the second number. So when I multiply this here, I take the 0 is going to be multiplied by the first number, whatever's on the top, so it's going to go away, and 1 is going to be multiplied by the second number, so that's going to be preserved. 1 times, well, I guess this first one is kind of a weird example because we get a 0 for both of them. But for this one, you can notice 0 times negative 3 and 1 times 5. So we kill off the negative 3, we keep the 5 exactly intact, and we get a 5 there. So you can see when we take the identity on the left times A, we get this matrix. We get the original matrix back. If we swap this around and we did A times I, well, this is a 2 by 3 matrix. In this case, the identity we would have to use would actually be the 3 by 3 identity. So we'd be doing, let me scroll this a little bit further. There we go. We'd be doing 1, negative 3, 2, 0, 5, negative 1, times 1, 1, with zeros elsewhere. And what we're going to end up seeing is we have kind of a similar sort of thing happening. This is a 2 by 3 and a 3 by 3. We're going to end up with a 2 by 3 as the result. And when we do this multiplication, this row is going to keep the entry of that first column intact and take zeros times these numbers. So we're going to get a 1 there. When I do this one, I'm going to take zeros times the numbers in the first and the third column, and I'm going to take 1 times this number here, and that's the only one that's preserved. And then finally, when I'm doing this column, I'll be killing off the numbers in the first 2 columns, and I'll just be keeping the third one intact. And you can see it just multiplies. It's exactly what we need, so that when we're multiplying, we only keep the one number that's relevant intact.